All right, Bettina, I think we are live.
Hello, everybody. Hope you can hear us.
Yeah.
Welcome.
Can you tell us how we sound? Is it good?
Yeah, give us a thumbs up.
Please.
Okay.
All right.
Good.
Sound good. So let's go.
Wonderful. Well, thanks everybody for joining us today for our latest workshop. Today we're going to talk about Spring Java microservices with Apache Cassandra. And we have the usual crew supporting you. So with me on the screen is Cedric. Thank you so much.
Oh.
He's really the Spring expert.
Yeah, I am.
I'm Bettina Sinnerton. In the background, we've got David Gilardi, Aleksander VOLOCHNEV, and Erick ZIETLOW supporting us today on Discord and on the YouTube chat. And we have probably a few others from DataStax popping in, helping out if needed. So thanks everybody for joining us. And of course, Jack Fryer. Sorry, I forgot to mention Jack. Jack is also there to support us. Even though we're not handing out any vouchers today. So, so no call for vouchers, please. Yeah, so I hope you enjoy the session today. And we're going to stream on YouTube and on Twitch, but we're not monitoring the chat on Twitch, only on YouTube. If you have really complex questions, I would say I would keep them in the community, so community.datastax.com, because then we have a lot more time to get look through logs and errors, etc., anything that you have. But for short questions, the YouTube chat is absolutely fine. And Discord, in Discord, we can also have direct messages, etc., and support you a little bit better. We're going to use Astra today. Astra is the hosted DataStax service in the cloud. So we will ask you to sign up if you want to code along. And if you want to follow the exercises, you will need to have a sign up with Astra. We show you how to do that. And we will run MENTI quizzes. If you've been to our workshops before, I'm sure you like the quizzes. So we show you later, we give you the code, how to take part. And if you haven't done it before, it's really easy to use, isn't it, Cedric?
Oh, yeah, very easy, yeah.
Wonderful. Actually, we will start very soon with a Menti anyway, to sort of like ask a few questions about you and to make sure that we get the audience right as well. So. But today, it's a coding session. We really, really hope that you're going to code along, right?
Yeah,
and we
please.
try to make it really easy for you. You don't have to install anything locally. You can code along using a Gitpod, and we will do all our demo and everything in Gitpod as well. Gitpod, you only need a GitHub account in order to launch Gitpod from our GitHub repository. So if you don't have a GitHub account, set one up quickly. Then we will show you how to use Gitpod. It's really nice. It's an IDE, basically hosted for you in the cloud. It comes pre-populated with all the code, and you can modify it. You can make your own changes, and you can really use it as any local IDE. It's very nice. So we will be using this today.
Yeah.
If you want to code locally on your laptop, you can absolutely clone the GitHub repo and set it up locally. That's not a problem. But today we'll just focus on that because we've had so many variations with Windows laptop here, Mac here, Java not installed, and all these kind of things. So we want to make it really easy to code along, and we really hope you're going to do it. So that would be awesome. Hands-on material. So this is where you get your Astra instance. Oh, actually, help us if you could just put those links into the chats if you haven't done that already. So that people can just click on that.
Yeah.
That would be great. So if you want to get an Astra instance, go to this link. If you want to see the GitHub repo, and we recommend that you look at the README while we're going to go along. So this is the link for the GitHub repo. And we've just put the documentation for the Java drivers, for the DataStax drivers in there. You don't need to look at them today. This is for your reference because we will be talking a little bit about the drivers.
True, and the QR code on top of me is the link to the GitHub repo. We have all the links, so if you do have a phone, that's maybe easier for you to move to this repo using the QR code.
I didn't even notice it. I've looked at the slides so many times.
Yeah, it's just hidden on top of me. above me.
Yeah, that's perfect. Yeah, that's much better than copying quickly. Thank you so much. Good, but let's start with Menti. So this is the code for today. So in order to use Menti, you go to menti.com, and we encourage you to look at your phone rather than at the screen, because Menti does a bit of a lag between the YouTube streaming, and especially later when you come to the quizzes, look at your phone. But for now, for the initial survey, whatever. So you can scan the QR code to get there directly, or you can enter this code 5564086. And I see that this is the first time I'm presenting with Menti, so bear with me if it doesn't work out. So
I will tell you.
Here it is.
Right away.
So I think is it presenting?
Yeah, so far so good.
Give me a thumbs up. Oh, I've got some. I've got 4 so far, 5. I have no idea how many people I should be waiting for. What do you think?
Okay, for now we are pretty low on YouTube, only 14, so maybe 10.
Okay, wow. That's 10? Oh, that would be ambitious. But let's see whether I can get to half. Come on, one more.
We do have time, so let's wait a little bit for people to join in the beginning. And all right, let me give you some thumb up.
Perfect.
That's me. Oh, I'm hiding the thumb up. Let me move.
Move on, yeah. Okay, so a few questions about yourself. So, have you used Apache Cassandra before? Let us know. Oh, I think I know who that is. 2, okay. Never use it. That's great. I think we really hope to give you a great introduction today, and we've got got a good spread of experience here. That's wonderful. So you can help each other out. Perhaps if you run into any issues, that would be great. Wonderful.
Please.
Cool. Oh my God, we've got more participants now. That's amazing. Okay, let's go.
More than on YouTube.
To the next one.
Unbelievable.
Have you been to any of our workshops before? Yes.
New.
Wow. No newbies. Oh, okay, so you know the format. What am I telling you all about Menti? So you know how
now,
it works.
oh yeah, so only regular people. Okay, so we can go fast. You will understand everything.
Exactly. You know everything. And how did our promotion work this time? How did you hear about it? No. Okay. Eventbrite, I think that's good. Yeah. So last week we had a lot of people who saw it through Facebook and Instagram, so that's why we added that to the. That's just interesting.
Yeah,
I mean,
that's we definitely need to see that nobody's coming from Facebook or Instagram.
Yeah, interesting. Okay, right. So now, much more relevant to today. Are you using microservices in production? The suspense is killing me.
Yeah, it's just.
What is going on?
I will see if it's working. Okay, I click.
Yeah.
Please wait for the presenter to show the next slide.
Refresh.
Yeah.
So
things a bit odd. Yeah, it don't let me in. So
I go back then and go back. Oh, there it is.
Yeah. It was. I don't know.
It was stuck. Okay. Oh, right, cool. Write my microservices. That's good. We have a slide on that. That's great. Not develop any applications. Yes, for all deployments. That's wonderful. Okay, and still ongoing. Actually, today we don't have any legacy. So yesterday we had.
Oh yeah, we had I wish, but legacy. Yeah, cool.
Yeah. Okay, good. Oh, thanks very much, guys. And finally, today's about Java. But I really think, perhaps we should offer some similar workshops for other languages. So what's your preferred? If it's not Java.
If it's not Java, click 2 times on the box.
Don't click 4 times Java. This is what Cedric would do.
No, I would use not an even number. It will finish and uncheck it.
Okay.
1, 3, 5.
Okay.
Okay.
Oh, good. Okay, that's enough.
So far, so good.
you know, if you can always let us know what you think we should be showing as well, right, for these kind of workshops, so we can take that into account when we do the planning. But yeah, I think it would be nice. Personally, I think it would be nice to have something similar from Python at some point. So let's work on that. Cool. Thank you very much. Let's get started and make sure I go back to my normal presentation. There we go. Okay, so today is about developing a microservice in Java with Spring to interface or to communicate with Apache Cassandra, and we're going to use Astra for that. And I want to show you a demo first, what we actually will be creating. And it is basically you're building the REST API for a to-do task, which is, I think, the hello world for database applications, right? We're creating a to-do list, and we're building the API to retrieve the complete list and to create, you know, a new one, delete them all, you know, update a specific task, delete a specific task, and you know, get details of a specific task. So the entire CRUD interface basically create, read, update, delete for tasks. And it's a simple data model, you know, where basically we have a title and we have a flag to set complete. And we have actually also a unique identifier to keep all these tasks separate. And I'm going to show you what this is going to look like.
Yes.
So I've set it all up for you here. So this is the Git pod interface of. So first of all, this is the README of the GitHub repo, and later on we're going to launch the Git pod from here. You can do this, or later on there's another button here, and then you will come to an interface like this, which really looks like an IDE. And I've zoomed in quite a bit, so my real estate on this is a little bit reduced. I hope that's big enough for you to read and see what but if it's too small, give us a shout and we can zoom in further.
Yes.
And anyway, so I've started the app already, and this is the Swagger interface for the app. And from here, we can interface with the Astra database, which is the hosted Cassandra service. So, and here I've gone into the SQL console in order to have a look at what task I actually have. So this is currently, I have one task in here, which I prepared for you for the demo. And so if I go to my API interface, and I want to see everything, the complete list of tasks, I can try this out with Swagger. It's very nice. So I can execute the task here. I get a success code, 200, and here I see I have the response body, and this is the task that I prepared for you earlier. And we can put another one in if we want to have a look. So we can create a new task. That's it. Let's put some in. Oh, yeah, it's already on. Something here. Another test task. Execute this. Again, I get a 200 response by the test task. And then we can go back into Astra and have a look. And there we are. So it's been updated into the database. So this is the entire flow, right? Now I could go and use one of those unique IDs and delete the task. So I go to delete a specific task. I try it out, put it in here, execute. I get a 2-4, which is successful. And if I now go to Astra and have a look what's in my database, the task that we earlier created has already been deleted. And similar, if I want to delete them all, let's have a look. Make this a bit smaller again. Delete all tasks in one go. Try it out. Execute. And now nothing in my table anymore. Okay, so this is basically how it works. So you can experiment with it. Later on, you might want to put a front end in front of it in order to interface with this API, in order to, similar what we had here in the presentation. And in fact, we have another more in-depth workshop that leads you entirely to this example application that you can plug in basically in order to exercise this API and visualize everything in a GUI that you've, so to have a proper application. We won't go entirely to this today, so we'll stop at the Swagger in order to make sure you can code along, you can fit it within the 2 hours, but we have the entire well-documented repository for you to take it that step further, and we would like to ask you, try it out, right? Okay. Good, so just the last thing I want to show you for the demo is what happened in my API itself. So this is here the log from my API. And so here I listed all tasks and I created a new task, list all tasks, again create a new task, delete a task, and then delete all tasks. So this is what we can see in our API logging here about the API calls that we executed. Okay, so stop this there, and we can start it later when we go back to the hands-on.
True.
Any questions? Did you pick up any questions?
Not yet.
Wonderful.
All clear.
Don't hold back.
Seems exciting. Real app, real app in the cloud. You don't have to install anything. It's working. Nice.
Yeah, exactly. No, exactly. So yeah, so let's talk a little bit about what you need to. So we've already said for Gitpod, you need a GitHub account, and but then it's free. It doesn't cost you. It's there. It's really quite powerful. It takes perhaps a couple of minutes to set up when you click on it, but if you haven't done it, I would encourage you just launch that, right? So if you go to the repo and you right click on it. If you click directly on it, it will just replace your repo page, and you might want to still have the README here. So right click on it or control click, and it opens in a new tab, and then you can sort of like switch between the tabs to have it. And the other thing we would like you to set up is Astra, so that you can actually access the database. So if you've been to our workshops before, you might already have one, right? And you might already know Astra. But basically, Astra is fully managed Cassandra in the cloud, and you do not have to care about the operations. So you do not have to install anything. You do not have to monitor it. You do not have to, execute any of those operational tasks like repairs and other things that you might have to do if you sort of run your own Cassandra installation. But for us, and for the purpose of this workshop, what I find most important here is that it has a free tier, and it's a generous free tier with 10 gigabytes of storage. It can be launched very quickly. You only need an email to sign up, and you do not need a credit card. So you do not need to enter your address details or phone numbers or anything, as I know. So it's free to use, and it should be a really nice tool for you to develop your own applications in an experimental stage, for example. It is, however, fully production ready. So we have we have quite a few customers using it in production, and it's very scalable and gives you all the benefits of Cassandra. So it's nice to get a first taste. So for hands-on work, we would really like you to create your Astra database if you haven't got it yet, just in case it takes some time to set up or you have some problems, because it really is kind of a central part of this, it's our database in the app. We want to make sure it's running.
And even if you do have a database, it may take some time to unpark the database. If you didn't use it for a while, it will be parked. So
that's very true, actually.
Go for it.
Will be unparked eventually, so don't get impatient. So we've set this up for to-do app for a new key space, right? But I've used a database that I had before from our previous workshops. So this is where I have inherited these username and password, and this is what we've put into the code. These are not things that are difficult to change in the code, but if you want to have the most seamless and most easy experience without changing any code, then you might want to stick with those values. And we actually do not need to download the Secure Connect bundle explicitly. We have a different method. We're just downloading it via curl directly into Gitpod. So you do not need to do this step. But if you could set up, first of all, let us know if you're coding along, and give us a thumbs up if you have your Astra database up and running. And if you have one from a previous workshop and it hasn't got the right key space name, you can continue with your previous key space. That's not a problem. Or you can create a new one. You can go to your Astra, I think I've shown it in the README. You can just click on the side and add a new key space. And it will get created. It might just not show up in the UI, depending how early you signed up to Astra. So don't get nervous about it. It will be there. Make sense? So who's coding along, Cedric? Do you have any idea whether we have any feedback on YouTube?
Not yet. I keep posting all the links, go to Gitpod, go to DTX workshop, go to the README. So people just going through the README probably. But, Jeff Smith telling us that it's okay. We do have the good pace.
Okay, perfect. Wonderful. Good. So now I hand over to Cedric, because yesterday Cedric presented this, and I must say I was in awe about, he's actually used Spring since before it was named Spring, right? So he is the right person to give the introduction to Spring, and I'm entirely grateful that he's here to support us.
Thank you for that. Yeah, I must be good again today, I hope. All right. Okay. All right. So, even before we introduce the Spring framework, I would like to remind you a pattern in the Java development, which is called inversion of control, or also dependency injection. Both are the same. Okay. And the idea is, when I use a service, I only care about the interface, the contract of the service. I don't care about the implementation. So here I put you a sample. I do have an interface called greeting services with a single method, say hello. Below, two implementations. First is in French, greeting services FR, answering bonjour. Let's do it with a French accent, bonjour. And also the one in English, saying hello. Okay, they're both implementing the same interface, and they're both having a name or an ID. The class on the right part of the screen is the one using the interface. This is a REST controller, the API you will build today. And as you can see, this service exposes a REST call, and it simply uses the interface. And this is based on an annotation here, auto-wired, and the qualifier that the frameworks know which implementation to use among multiple implementation of the same interface. And if for some reason there is a single implementation for this interface, you don't even have to use the qualifier keyword. So the ID is really now, as a client using the greeting service, you don't care about how it has been implemented. You only care about the contract. And that's very useful to be able to switch from one to another. And that's also a good pattern to introduce loose coupling between layers in your applications. So let's go now to Spring. Next slide, please. All right. So I don't reinvent the wheel here. This is a screenshot from spring.io webpage. So Spring is now supported by Pivotal, part of the VMware company. And now you can see that Spring is doing a lot of things. This is up-to-date developing patterns and trendy subjects, microservices, reactive, cloud, web apps, serverless, event-driven, and batch. So for today, we are focusing on microservice. But in the coming weeks, we do have content about reactive, about cloud, about serverless. That would be nice to cover mostly each topic. But today, let's focus on microservice. Okay, let's go. All right. So Spring has been created in 2002, something like that, by Rod Johnson. Rod Johnson was a guy that wrote some books about how to handle the G2E technical stack. Application server, you may remember WebSphere, WebLogic, Tomcat, all this nice G2E providing a lot of features like filters, authentication, transaction management. They were all handled by the application server. But it was pretty a fat application, kind of monolith. And so you deploy your application as a WAR file, remember, in those application server. But after that, you were just stuck. Everything has been delegated to the application server. It's not easy to scale because now then you need another instance of your application server. So this Rod Johnson wrote a framework called Interface 21 just to implement some lightweight functionalities to handle exactly that. So resources, internalization, validation, data binding, database connection. But at the heart of this framework was really the dependency injection in version of control ID. So I think Interface 21 was very official in 2003, and it has been renamed a few months later, and Spring born in 2004. So now Spring is defined as a comprehensive programming and configuration model for modern Java-based. Is really a way of thinking, a way of developing application. When you start embracing the Spring approach, you do have the skeleton of your application and you will add modules and features where you need them. Speaking of features, so in the early stage, Spring provide very quickly a MVC for model view controller pattern, implementing views, and also the controller giving data to the views, and the model is all about entities. Also providing a REST APIs, and now more recently reactive. At the data access level, Spring JDBC was there very soon to handle all the interaction with the database, competing with Hibernate. Hibernate was a bit too magical doing mapping from object to database, but sometimes getting some issues. So Spring JDBC is lighter and did the trick. Okay, more testing integration language. This is a lot, and you will see in next slide, this is almost more than you think. But if you just click next, Bettina, you see what we will use today. So we will simply focus on dependency injection at the core, create a REST API with multiple layers. So a layers to do the REST, a layer to access the database, and a unit test to test the two layers. So let's see what we will do. As I told you, if you go to the spring.io website, you see how many modules does Spring provide now. Things for web, data, cloud, remember all these big categories. It can be overwhelming, but today we are really focused on the basics, which is Spring Boot. Okay.
But it's also quite interesting what you see here, like, Spring Cloud, GCP, Spring Cloud, Netflix, Zookeeper, I think I'm quite interested what else you can do with it. So
true, that's totally encapsulate existing API, and you don't have to create a client to invoke those on your own. It's all done out of the box. That's pretty neat. Kind of SDK.
Perfect. Yeah, and here we have the Spring Data for Apache Cassandra. This is not something that we use today. But we plan sort of like a more, it's actually used in this other workshop, which is a bit more involved into this. And I think you might use it for your reactive repo.
Absolutely, absolutely. We do have the reactive data stack driver for Cassandra, and I also use the Spring Data Cassandra reactive framework.
Perfect.
And I can, and for those interesting, please say so on the chat, and I will give you a link to a sample to use Spring Data Cassandra. All right, back to Spring Boot. So Spring Boot provides a lightweight runtime for your application to run. You don't have to use an application server anymore. This is your own component that create the runtime. And this is a game changing, because now if you want to scale your app, you simply have to instantiate it multiple times, as you don't rely on any application server. You simply have to put a load balancer on top of it. And Spring Boot is used in a lot of microservice architectures, especially for Kubernetes, when you have to easily scale. It's quite easy to start a new container using Spring Boot and having that running. Okay, so it's providing the box, the big box. And in there, you will develop a traditional Spring application using the presentation layer, REST with Spring Web, the business layer, classes you define to do aggregation and mapping of data coming from the database, the persistence layer, which is the closest layer, the layer closest to your database, using the drivers. So Spring Boot not only allow you to do the Spring application in the proper way, but also provide you a lot of tools. By adding some starter, you can have an extra features. You'd have Spring Boot Starter Web REST API, Spring Boot Starter Actuator, then you get metrics, health check, monitoring, Spring Boot Starter Security, yeah, now your API is secure, Spring Cloud, and now you can interact with cloud services. So it's all about adding module, namely starters, to add features. But for today, we will only use the starter web to expose an API and starter test to be able to do a unit test with a Spring context. All right. Speaking of layers in a Spring and Spring Boot application, fortunately, it's like this hamburger, multiple layers. So classes that would interact with databases are called repository. Most of the time is one repository per database technology, and even one repository for class. And the create, read, update, delete will be defined in a different repository for each class. Then, depending on the service you want, let's say you need to access multiple tables to execute a business function. You do have a table holding the product and another table holding the customer. And you do have a UI telling, I want all my orders of the day. So to get all this value, you need not only to query the customer table, but also the order table. And as such, in the service, single method, single invocation of method, inside you will compose multiple access with multiple repositories. And so how it works, you will define a database connection that you will inject using inversion of control in the persistence layer, and you will inject the persistence layer in the business layer, and you will inject the business layer in the presentation layer, which is for us a REST API. But now, if your REST API only interacts with a single table, there is no real interest to implement an intermediate service layer. No composition, no mapping, no translation. So it's not an anti-pattern to simply inject the repository into the controller method. And this is exactly what we will do today. It's a simple to-do app with a single table to-do task. So we will skip the service layer.
Perfect. You see, I think there's just nobody who can explain this better than Cedric.
Thank you. Thank you, Rich.
No, honestly. So let's put it into action a little bit and actually plan our microservice. And actually, this was a question, and some people answered, what is a microservice? And we've picked this up from the workshop series that we ran earlier in the year. That perhaps is not such a term that is known, right? But I see it as basically a very simple, self-contained function, that you want to, that's as part of a bigger picture. And you can swap it in and out. It's loosely coupled. It's independently deployable. And it's tightly organized around certain business capabilities. So it's really the opposite to the monolithic application implementation that is difficult to change and difficult to swap out. Would you agree?
I do.
Cedric?
Oh yes, I do. I just answered my question, but I do.
Good. Okay, so what are we building? Come back. So we're building a to-do service, and let's think a little bit how we want to plan that. So this is the REST API that we want to expose. Just to repeat, we want to be able to create, update, read, and delete tasks, and we also have these additional APIs where we want to show all and delete all. And the architecture really will look like this. This is our Spring Boot, where we use the repository that we're building, and we use the Spring Web starter component, and we will use Swagger as demonstrated, so that we have a UI in order to exercise our API and show that we have the connection to Astra. So, and we will use Astra as our database.
Yeah.
And if you've been to our workshops before, we always talk about the data model and with Cassandra, so we cannot possibly skip over this today. Let's think a little bit about that. What is the data model that we want to have in order to display our tasks, our to-dos? And we definitely need a title, right? So we need to what it's called, and we need we want to have the ability to mark it as complete or not complete, as a proper list. We actually do not need an order necessarily, and this is left over from the previous, the previous workshop that we did.
Yes.
We're actually not going to use the order today. It's still in the data model. I've not refactored it to take it out. It's still in there, but we're not using it. But for our Cassandra purpose, we introduce a primary key which is unique, right? Which is the task UUID. And my example is, I have to do certain tasks every day, right? I feed my cats every day. And so I might want to show my husband that I actually did feed the cats. So I would have feed the cat, feed the cat, feed the cat several times, but they're not the same tasks. So we want to keep them separate with a specific UUID to keep them separate so we don't override them. Okay. And if you've been to the data modeling workshops that we've done and the introduction to Cassandra, basically we look at the queries that we have, we look at the entities and relationships that we have, and we map it all down to a physical data model that makes sense in terms of the implementation in the database for optimal reads and for optimal writes. And we arrive at a data model that would look like this. So we have the concept of the primary key. So this is the most important part of the table. This is how we look up. We will look up the task by the primary key. And then we have the title and a Boolean type for completed and an integer for the order, which we're actually not enforcing or using here. So, but this is basically the table that we will create in Astra. And also in this app, we only have one table. It's very simple. So it's meant to be a very, very simple starter application. But then obviously you can add additional, you can add something like a task by user or, and a table and see whether you can get that to work and experiment with it. It's really something to give you a starting point. And I put that slide in there because to just come back to, we're building up this, actually to be fair, we're building up the to-do list repository. And we put the definition of the task basically in there of the table. So this is the table to do tasks, and these are the different column names. And this is what we will then just refer to, right? So if you make any changes here later, they will be propagated by the auto-wiring throughout the entire application. But so this is the interface that, in terms of this inversion of control that we care about, right? So this is what we have. And we're going to roll in the queries in there as well. So the queries for the tasks is basically list all, create a new task, mark one as complete, incomplete, delete all. This is basically an update, right? So this is where we're updating a field. And then we're adding this to our repository as well. So obviously I haven't got the full list here because it's a little bit longer, but basically these are the functions that we actually do, So the upsert, which is in Cassandra terms the same as an insert or as an update. We have a delete by UUID here. We have a find by UUID, and we will have to delete all and the find all Good. So once you have the interface, right, and we need to create at least once the specific implementation, right, in order to propagate it down to the database, and then expose it through the framework for all the APIs who want to use it, right? And so it makes sense to talk a little bit about the driver, and which is the main technology that we use in order to establish that connection and execute our queries. So we will use the data snacks driver, and basically which communicates with Astra. And we don't need to care at all how Astra is actually deployed and how our database is deployed within Astra, how many contact points we have, how many nodes, etc. So this will all be handled. What we need to care about when we connect with Astra is that we have the username for our database, we have the password, we know the key space name in case we have several key spaces, and we need to have the secure credentials in order to handle the authentication.
True.
And we get that provided to us as part of a Secure Connect bundle, and I'll show you in a moment in the first hands-on how we can actually create that and bring it into Gitpod. Okay. But let's talk a little bit about the drivers, what they can be generally. Today is about Java, but we have a lot of different drivers for all sorts of different languages, and they basically provide really the same functionality. There might be a little bit of variation between certain drivers depending on the language, but ultimately they are token and data center aware. They know how Cassandra stores data, right? They do all the load balancing. They have certain policies in order to overcome failures like retries, reconnections. They handle the authentication and authorization for you. They know about CQL, of course, which is the Cassandra query language, and how to construct a statement. And we have certain helper functions like query builder in order to make that easy, and they help you sort of retrieve the results and paging through them in case you have a lot of data and you certainly do not want to download the entire database in one call, right? So this is, and here today we're going to use Spring Support, which is in the driver. So a few words about a session. We need to establish a session to open a session to the database, and we need to pass the credentials as part of the session in order to establish that. Here you can do it explicitly, right? You can tell when you build a session, you can tell use this secure bundle. This has all my credentials, and then I have these additional authentication credentials like the key space and the password and user, and use all these parameters in order to establish the session. So, but there's a lot, there's a lot more connection-specific parameters you could set, and it could become, quite unwieldy to put them all into the initial build statement like here. So there is an alternative way of configuring your session with the application.conf. So this is a configuration file which will be used by default by the driver, and where we can define all these settings up front, and then the session creation looks a lot simpler. Basically, all the definition is the configuration is delegated to a file, and here it just uses by default. It just assumes that you have the file, and it takes these configurations from there. Okay. Important, you should really only have one session per application, right? So in order to handle this as a singleton, there should only be one, and it's also good practice. I don't actually think we've got that implemented in our example to close it down explicitly. I don't think we have that in there, but it's good practice to make sure that you free up any open sockets that you've used.
True.
Okay.
And we are using the pre-destroy annotation, which is an annotation coming from Spring.
Okay, but I don't think, do we have it in our example? I actually don't know.
It's hidden somewhere. Let me find the proper class. It should be there.
Okay, perfect. Good. Right, so let's try it out, right? So we've prepared a couple of tests for you that actually don't use Spring, they just use the tests. And where we connect first with a static connection and then with the application config. But let's go first and make sure that we can actually access our database. And so for that, we need to get the secure connect bundle into Gitpod. So currently here I have here my credentials.zip, and if you want to download that from the Aster database, you need to go to your database, to your connection dialog, right? So as I said, the UI actually hasn't called up that I'm using a different key space. So I'm using a key space to do app, but it's still showing that I'm using killer video. That's fine because the connection bundle is not key space specific. It's for your database. And you can either download it directly to your laptop, right, and then upload it again to Gitpod. But if you want to save this step, you can just click here and copy the link to the clipboard, and then we use it in a curl command. Something that you might want to be sure, if you've had this open, like I've had this open for a while now, is you want to refresh your database here. So that you get a freshly generated link, because the link only is valid for about 5 minutes or perhaps even less. And then you run into really weird connection issues because not everything is in that connection bundle. So you copy it to the clipboard, and then you basically go, make sure that you're in the Spring Boot to do app. This is the root where we have the POM. And then you do a curl minus uppercase L, and wrap it into quotes, put it in there, right? Wrap it into quotes and redirect it to a file. If you really want to have the least hassle in terms of changing names, etc., redirect it to a file called creds.zip, and then just hit enter and wait for it to come. This was very quick in my case, it's already there, and it should be about 12 kilobytes here. This is
about 12 kilobytes, yes.
Yeah, so if you have only 350 bytes, then you've used an old expired link, and it didn't actually include an essential configuration file that you need to have in that bundle. So that's the way to get it. Very easy, so you don't need to download it locally and then upload it again, and now it's in Gitpod.
Yeah.
Should be. I'm not sure. You keep an eye on it, how people are coming along.
Yes, so people ask if they have to clone the GitHub repo. So I say no, you could simply click on open in Gitpod. As long as you do have a GitHub account, you're good to go.
Yeah, so basically in the repo, in the README, you can right click on here, and open in a new tab, right? You might actually not like it that I try to do it again for the same project. But this is what it would look. It's pulling the Docker images. It's initializing the workspace. It seems to do 3 out of 3 tasks before it's complete. And then I think in my case, it might actually say, hey, you already have a workspace. You want to reuse that. So I think I stopped that here. Oh, no, it came back to this end. So I hope it's not kicked me out of this one now. So yeah, and then again to get, so you start in this root, and then go into CD Spring Boot. This is the root of the project, where we have our POM in there, which we need in order to run anything really. And then we ideally want to have the credentials zip in there, right? It's not a problem if you have it somewhere else. We can always copy it in there, or you can amend your link. But and in order to get it, you just again you do curl minus L, and make sure you wrap it into quotes, because otherwise it seems
Yeah.
to succeed, but it gives you some really strange errors, right? So it needs to be wrapped into.
Yeah, and if the zip is not completed when you use it, there is a weird error telling you that a JSON has not been found. Yeah, make sure that the credits.zip is big enough.
Exactly. Cool. Is ready to move on? I think I'll just show you.
Can you give us a thumb up to say that you are okay to proceed? You have opened Gitpod and the database is ready? Waiting for people. So, all right. So Akshay B telling that he's ready.
Perfect.
I think Jeff Schmidt is in progress.
Okay. Well, we can wait. We have lots.
I think so. I try to guess, you know.
Racing to the content.
I try to guess. Okay, I got the question on Spring Boot. Okay, I think we can wait a bit. We are not in a hurry. Yeah.
What's the question that you see?
Oh, about Spring Boot. Just where do you put the application, the configuration file? So which are the configuration file and where should you put them? And so I simply said in resources folder, you do have two application files. So application.conf for everything related to the driver and application.yaml for everything related to Spring Boot.
Yeah, so application.conf here is for the driver, and then we have quite a few other things.
Okay,
here.
and also, so what is what is the target directory? So target is where all the classes are built. You know, this is your build folder. So you will see all the .class and eventually the .jar, which is your deliverables. It's done in the jar, in the target. Yeah, you see, Bettina just show that it only contains classes. And when you do Maven clean, it will remove this folder. Simply put.
It will remove the entire target folder. Exactly.
Yeah, true.
So if you don't have, so you probably don't have a target folder up front, right? Unless I think we put some pre-built commands into Gitpod now. So it probably pre-compiles it for you. But if you don't have a target folder yet, it means you just haven't compiled it yet. Actually, did I skip this step? I think we've put it into the pre-compile, but if you know the mvn clean install, you could run that. If you don't have a target, then you want to have that. So you put it in there and just run it. So this skips the test because you might not have set them up, and you can just run it and then it just downloads everything that is needed. In my case, I probably have everything in place. Oh no, it's not downloading. It might normally download a lot more. So
yeah. Remember, Maven will download everything needed for compiling and running the sample. And you might also notice that Maven is pre-installed on the Gitpod. It's a very complex, very mature and very complete IDE. With Docker, Maven, a node, all those commands are ready to go, ready when you open the workspace.
Yeah. Okay, so I hope we can just have a look whether we can execute these tests. So I can show you. This is so first of all your sources are in the source folder, right? And then we are going to concentrate first on the tests. So we go into the main in a little bit, but let's look at the tests first. And then here we have four tests, right, that we've created for you in order to show you the different stages of the driver. And for this one, we're going to start the first two tests. The first one is the explicit connection, right, where we explicitly define everything. So we have here our zip file location. So if you followed along downloading your credits, you wouldn't need to have any change here. If you put it somewhere else, you want to make sure that the path matches. then you might want to update for your Astra username. If you're using a different Astra username, you might want to update for password and also for the key space. So make sure that this matches what you've defined. And then we have a explicit creation of the session here. So we're building the session and we explicitly tell that to use the zip file and which username and password and which key space, and then we build it. So this is the first test. So this is not using an application configuration file. This is just using, we defined everything explicitly in there. Which is obviously, if you want to change it later, say for example, if you have different connection settings for your test than to your main application, you would have to go back in and change these things. Okay. Good, and then to run it. So I think in order to run, so there's there we are. So to run the test, this is so basically it's the name of the class and then the name of the test in there. So this is the syntax, and we just paste it in there and see whether we get to a successful connection. So it's running the test. And here it looks good. Okay, connected took us to, where was it? Oh, just saw it here. Okay, connection established to Astra with key space to do app. One test run, no failures.
Great.
All good. Yeah? So hope you get to that. And then alternative, this is the other where we actually use the application.conf, the configuration file. And you could have separate ones and you can define it very explicitly which resource to get. In this case, we're just using the one that we are using in the main as well, so that we don't have to go back in and make changes there. So it's in the resources of the main. Let's go back here. Here in the resources folder, here's our application conf. And here we put everything that's relevant for us. So here is the session key space. The secure connect bundle, we explicitly, so the path needs to match where you have yours. Again, you might have your, your own username and your own password. You would want to change that. And the key space needs to match, right? So these are the 4 things that you need to provide. But then here's, for example, an example of how you can add additional things to your connection via the application.conf. And we've just put some very generous timeouts there because my internet connection can sometimes be a little bit slow, and I've run into issues with the, the feedback from Astra that I didn't get it fast enough over my connection. So this is very generous, and I don't think we actually still need it. So.
But here you are, you are logging.
The floor?
Yeah, here you are logging from Gitpod. So who? I don't know where the request come from. Is this from your?
Very true,
is it from your laptop because it's a JavaScript and the request is issued at your laptop, or it's a backend code and this is invoked from the Gitpod container and then it can take some time. So that's a good.
True,
that's a good. Yeah, that's a good guardrail to keep this connection. And for you watching us, maybe you do have a slow connection at home, and that would be always good if you clone the repo to get this nice improvement instead of just running into issue for no reason.
Yeah, no, that's a good point. Yeah. So I've not experienced this from Gitpod, but I've definitely experienced it from home. So, but we just want to make it easier for you. So let's go back to our test and actually run this test. So once you've got your application.conf fully configured for you, then we can run this test. And I go back to my cheat sheet here and make sure I find the right test. Here it is. Again, this is just the class name, connectivity to Astra with conf test, and then this is the test, should connect to Astra. We're hoping that it will do that. And that's a lot of hope, isn't there?
Yes, this is what I was about to say. That's a lot of hope.
And we should see exactly the same thing, because we're basically just doing the same kind of connection and establish it in the same way. Only that we've put our settings into the application.conf, and we did. So it was successful. Again, we have an OK connection established to Aster with key space to do app, and all done. Okay, good. So how's everybody looking out there? How are the tests going? Are you playing along?
I think we have good feedback here.
Perfect. Good.
Yeah, good pace.
Okay, so then let's have a look at some other driver things, because obviously the connection is only part of the business, right? We really want to talk to the database, and we do this via execution of queries, right? So this is the main thing. So we want to execute. We use the execute method. Very simple, and we can basically just put a string in there. We can put a statement in there the same way as we would do it in the SQL/SH console, and it will execute it for you. But you might want to work a little bit smarter, right? So this is called a simple statement. This is just what it is. It is a very simple statement, but the driver gives you a couple of additional methods in order to work with simple statements, because you might want to parameterize your queries, right? So that you can, and it's actually a smart thing to do, right? So you don't always want to construct the explicit simple statement first before you put it in there. So here's two ways how you can parameterize. So you can either add the positional value, or you can add a named value, and here your placeholder looks a little bit different. Right here it's just a placeholder of a question mark, and here you actually name the variable that you want to insert, and then you name it. Right?
Yes, so a question here, SQL injection is like SQL injection. It's like, yeah, people putting some wrong statement, trying to use attack like buffer overflow or wrong interpretation of the SQL to really attack your app, and inserting, I don't know, some JavaScript code or maybe something like that.
Yeah, or you insert some database code, delete all tasks, as a name, right?
Yeah, it looked like prepare statement, but yeah, we are coming to prepare statement right away.
Exactly. So yeah, so the other thing, and the even better practice, is that you prepare your statements up front. So you basically compile them, and they're locally on the driver. The driver knows about them, right? So you don't have to do them again. So it's more efficient. This is for a much more efficient execution of your queries. And in fact, if you hammer your Cassandra nodes with a lot of queries that you haven't prepared, you will actually sort of like get a warning at some point, because it's really inefficient. There is a cache for prepared statements, and if you don't prepare your statements, every new statement will be treated like a prepared statement. So it's a good practice to sort of reuse your queries, right? And so here you prepare it, and then you bind it, right? You bind the parameters into the prepare statements, and then you just execute the bound statement. So this is the driver has prepared for you the full statement to be executed out of the pre-prepared statement together with the values that you give it. Okay, any questions on that?
Not yet. No question.
Then something just that you want to know, what do you actually get back from the database? What kind of object do you get back? If you get a result set, right? So this is what is returned from your execution statement, and then you can do various things with it. You can get additional information about your query execution, the execution info. And I actually haven't used that very much, but Cedric knows a lot more about it.
Oh yeah.
But also, otherwise you get your database rows, and then you would iterate through them in order to retrieve them. And the idea, of course, is you don't get all your data immediately, right? So you really don't want to. This is for big data. You might have potentially a lot of data in your table, and you do not want to overwhelm your driver.
True.
By getting everything immediately, right? So there are some guardrails in there that there's a sort of like, it only gets you a certain amount and then pages to the next. Do you want to say few things about the execution info and
so simply put, in this part you do have the execution time as stated here, and also if the query was applied or not, if you are using a lightweight transaction, and also if you are using paging, this is where you will find the page size and the page state to go and fetch the next page.
Okay, perfect. Good, and then so that's how you work with the result set, right? So if you know you only have one result, or you just want to get the first result, so you have result set 1, then you can get all of them, but make sure that you limit it. Here you would how to iterate through it, and then you can also exercise some lambda functions on it, right? So if you want to do something specific with the row that you get back.
True.
And then you have a lot of different reports, to check, So these are the things that are actually, we have differences per driver, right? If this is how it works in Java, some of those additional methods on the row might not be implemented, or might be implemented differently in other drivers. For example, we don't have this is now, for example, in Python. So this is really how you work with the results, and we will see some of those examples in the code that we use today. Okay, now let's do a bit more hands-on. Make sure that we actually can, because the first hands-on now is that we actually create a table, and creating the table is actually the same as executing some simple statements. So it's the driver just see it as a a SQL statement, and it's a table creation statement. Let's go and show you in the code. So this is the third test that we're running. So in the third test, basically you see here we're constructing our simple statement here. So first of all, we have to import the simple statement as well from the driver. Here it is, here's a simple statement, data types. We're going to use a schema builder as well. So these are the things that we use from the driver. And here we are creating the simple statement. And here we are taking the to-do list repository in order to get the definitions that we set up for our, for our table. And we keep that in this case because we don't want to define it several times. We have it here in the main, and we have, I think this one is this is the repository where we set up, and this is here where we set up basically what our table looks like, the name of the table and the various columns, and we're pulling those values from this one definition from this interface, just as an example, that we only have this one place where we define everything. And we're using that here in our schema definition, right? So the simple statement, we create a table. We're using the schema builder to create a table, and then we just pack it all in there and ask it to build. And that creates this simple statement, and then the driver will execute this simple statement. What we're doing here is we have here a flag if not exists. So the table will only be created if it doesn't exist. And of course, if you didn't have that and if you created it again, you might actually get an error. So if you want to run this, again, back to the README, and there we go. Let's create the table. This is the class, create schema in us for test, and it should create the expected table. So there we go. Let's run it. So again, we established a connection, and let's put this up here perhaps. And to-do table has been created, but of course, it can tell us anything. We can, if we want to be absolutely sure, we can actually create. We can actually drop the table and recreate it again. So let's have a look. And have a look at the tables. Describe. There's a to-do task in there. If you just look what it looks like. So this is our create table statement. statements. Basically, this is what we gave the driver, and this is everything else we put in there because we didn't specify any specific options. And if we want to, we can drop it now and run the test again and see whether it actually gets created. So we can drop the table. Did you have a question or comment?
No, just a comment. Won't say anything about that.
So now if I look at the tables, there's no table in my key space. And if I go and run this test again, it should create the table. Connection established. Table created if needed. Go back to Astra. Yes, there it is. So it's been created again. So we are definitely connected, and the execution of the simple statement worked. Okay. And the next tests that we would like to do is that we insert some test data into this, and we use the next test for that. But let's see whether, do I need to wait a little bit? Is everybody caught up? Is the table created? Okay. So let's have a quick look at the test here. So this is the quad with Astra, and here we're having the beans for the CQL session and for the to-do list repository that we're using. We're using the CQL session and the to-do repo. And here we are defining basically the values that we want to put into our task, right? So we're creating here a random UUID, and we're putting, actually we don't need, I think I put that in there to just see what we're creating. And then we can put a task in there. So this is this is a task created by the test. Okay. And we're setting it to true because we're already creating it. And then here, this is now the construction of a simple statement. So this is an example of how we use a simple statement with a simple statement builder. Again, so here we see our template basically, and then we are putting our positional values in there. So the sample UUID here, and then the title and the order and the complete, and then we're just executing this. Let's try that. And I should actually, good point. You see here, you need to save. You need to save anything that you do in Gitpod. It doesn't auto save, or it will not take the values that you just put in. And let's run this test. That's it. Okay, so test run, successful. Let's have a look on Astra. If we select everything from this table, there we are. This is the task that we created by the test. So the connection with Astra works, the insertion works. So I think we've got enough tests in order to move on to our proper application. How is everybody doing?
They are quiet, to be honest. They should try to do to run the test. Can you give us any sum up or anything just to say you keep up, you are able to execute the code?
It's a long README, isn't it? I think I should probably put some more sort of like checkboxes in here so you find the
okay, we got some feedback. We are good. Thank you, guys.
Oh, perfect. Oh, I'm so delighted. So cool. Right. So let's see whether I think I might have some additional slides here. No, I don't think the rest.
Okay. Yeah, you should. Let's wait a couple of minutes. Let's do. Yeah, I get some SAR feedback that we should wait a bit. And creating the table is nice. So let's give him. We are not in a hurry. I think we are moving fast, to be honest. So I think we can wait a bit for him.
Right, okay. Oh yeah, perfect. Good. Yeah, so you can of course also experiment and put, change your table and insert additional columns.
True.
And
yes, but the statement is create table if not exist. So if a table already exists, you won't see new tables. You should try to drop the table. Maybe you can show how to drop the table and recreate it. Maybe.
Yeah. Okay. Let's do that. So, in the code. Yeah, I think that might be something.
In SQL, yeah. Here you can drop here and re-execute the code.
Yeah, you can drop here. So I did that earlier. So here you should drop the table. So you can drop it here.
Yes.
And it just goes.
So if you try to describe now, nothing there.
So I do a describe. Nothing there. It's empty. So I could now either go and just copy this one out, so and insert it via SQL LSH. I could do that. Or, as I can just run this test again. I run the test that creates the expected table. And so if you have a lot of tables and a lot of nodes, especially on your production database, you probably don't want to drop tables and recreate them and drop them and recreate them all the time, right? So these are schema changes that so just need to propagate to every node in a database. If you have a distributed database, you don't want to necessarily do this all the time right on the fly. But for such a simple app, this is not a problem.
Yeah, true.
So, and that should now be here. So let's have a look.
Yep.
Add the tables. It's up again. Okay. And we can put some more data in. So run the other test again, just to do an insert. And I can modify my values and do another insert here. So to say second task. And run that. So then I should have 2 tasks in there. Yeah. So it's not there yet. So then still running. Now I should be there. There we are. There's the second task. Okay. And this is an auto-generated UUID. So So this is what the driver does that for you. So this is not a problem. Personally, when I sort of do my tests, I usually just use text IDs. It's much easier to write them. So, but okay. So are we good? Do you need a little bit more time?
No. Let's see. How do you? Did you catch up? Yeah. Okay. So I think we can go. Oh, Ashish 2199. Okay.
Ashish, you were there yesterday.
Yeah. He's come back for the swag.
Oh, that's perfect. Yeah, that's good.
Ashke as well. Akshay as well.
Okay, next one.
Should we put a rule like, you can get the swag once, but let's give a chance to anyone?
Oh, don't worry.
No, I won't. I don't want to shut down anybody. Okay, so we're good.
Perfect.
A lot of
So let's have a look what we're actually going to build. So because now we just cobble it all together, right? So we have let's have a look in a moment at the repository. So this is the where we have our schema definition in there. We have our queries in there, and then we have our SQL session, and we look at that in a moment. This is our main bean here that sort of like implements our SQL session, our connection to the database, using the application conf, right, where we have our configuration set. And that feeds now into the implementation of the repository, which is specific for the Cassandra driver, right? And so we're going to look into this in a moment. That uses the session and uses the definitions that we have in the interface, and that then feeds into our REST controller, into our API, where we so these are quite long files, but this is already quite a long file. We're going to look into this and see how the statements are created there. And then this obviously is a much longer file, especially with all the Swagger annotations that we have in there. So we just look at a couple of examples, but then by all means go and play with it, modify it to your heart's content. Okay, so let's have a look. Let's go to the application. Let's tidy up a little bit here. So it's put these various things that I have here. Oh, there's so much stuff here. Okay, so let's look into our main application here. So we have first we have the repository, right? So look at the repository here. So this is the to-do list repository Java. Here we have the public interface where we define the tasks, the model basically that we're using, and here are the various functions. And it's a short API here. We just have find by a specific ID, insert or update, the same in Cassandra, delete, and we find all of them or we delete all of them. So if we look into first of all, we should probably look into the configuration of the driver that we're using. So here's the driver configuration. And it's very simple similar to the test that we did, right? So we basically just create a session and we rely on the configuration that we've put into the resources folder here. So the driver goes by default to the application.conf in the resources folder. And this is exactly the same file that we use for our tests. So that should all be set up fine for you and working. And we're just basically using it here. And then if we go into the specific implementation of the repo, which is here this class, to-do list repository Cassandra driver implementation, a really nice long name, right, which implements the to-do list repository.
But it's clear enough.
And here we have, it's clear, absolutely, no, it's fine. And you don't really need to care about it that much, right? Because you're actually only specifying later in the application that you want to use this repository, right? And here we give it a name, to-do backend repo Cassandra driver. So this is in case we have several implementations that it picks the right one, right?
Yes. And we got a question regarding Spring Data. So yes, indeed, if you are using Spring Data repository, you will only define the interface, and Spring Data will provide you the 4 default methods, which are find by ID, find all, save, delete by ID. But be careful, because find all will exhaust all the data, no paging. So yes, it does a first level, but you also need to understand what's happened under the hood, and sometimes you have to add your own method on top of it to adapt to what Cassandra really does.
Yeah, that's actually a really good point, right? So I think it's don't they say Spring Boot is an opinionated implementation, right? So it does what you think is right.
Oh yeah, no, Spring Data is very good. Yeah, don't. I don't say it's not good. It's very good, but it's doing one thing very well, and you have to understand what it does. Because if you need more here and there, then you will use what they call SQL template, which is using back the SQL session. So yeah, be aware of the limitation of the existing repositories, and that's it, no more.
Okay, perfect. Okay, thank you. Wow, I'm so glad Cedric is here.
Yeah, no problem. Okay. And also in the past, Spring Data did not implement prepare statement because it's all dynamic, and so it must create a simple statement each time. But now in the very latest version, Spring Data 3.0.0, there are some ways to create some prepared statements. They call that
interesting.
prepare statement creators. Yeah, you should go read the documentation. So again, prepare statement should make your query faster because you evaluate the grammar and table existence, column existence only once. Okay, I'm done.
It's really best practice to use prepared statements. Actually, we use in this repository, if you want to look really into the code, and we would like you to read through the code as an example. We're using a couple of prepared statements, for the find task, for find all, delete task, delete all. But for the upsert itself, we're actually using a simple statement. So here, for example, is the upsert method. And here we are constructing the simple statement similar to what we did in the test, right? So we basically have our template here, and then we put positional values in there, and then we execute it. So when you go through this, you will see the specific implementation for all these methods. So this is for the find all. And then here we're using the prepared statement that we had probably prepared somewhere up here. Where is it?
It's in the bottom, init statements.
The bottom?
Yeah. Yeah, you got it.
Here, there.
Yes. Yeah, you got it. Yeah, it's there. So
the
first you create the table, and the idea is if you start the app right away, then it will create a table. You may want to just start the sample without executing the unit test. And then here is the prepare phase.
Okay, perfect. And this is the find all, and basically here that's what it does, prepare, select from table to select all, basically. And this is what the statement builder does for you in the SQL session. So you don't actually have to write explicitly select all from this table. So the builder does that and then gives you the ability to bind it later. And that's what we're doing here in the find all. Okay, so this is what we this is the specific implementation, and then we go to the REST controller. So I think since this is so big here, you can switch. So this is the REST controller. First of all, perhaps we should sort of say this is the main application where there's not much happening in this application, right? Basically, it's just annotated with Spring Boot application. Just run it, right? So this is what the Spring Boot does for you. But here is the REST controller, which is really our main application here. And there we go. So here it's annotated with REST controller. And then there's a couple of things that are really there in order to support the Swagger, right? So the tags and a couple of other operation API responses. These are all sort of things that the Swagger UI renders for you and is usable. But this is the important bit here, right? Where we're injecting basically the repository or the implementation for the repository here with the auto-wired. And this is the qualifier that we're using, the to-do backend repo Cassandra driver, which we set up here earlier in this one. Right? So, and then you basically implement what you're going to do, what your responses are in order for your API, right? So here is this is the Swagger annotation, retrieve the complete list of tasks, etc. This is the API responses that we want to have and expect. And then basically here, this is the response that we're getting. So to list all the tasks. And for all the other various APIs, you will see the same thing if you go through this in more detail. Okay, so in order to run it, so this is run. So this is how you run it. And it's
yes.
fine. So you might see slightly different because I've run this before for the demo. So my port is actually already open. So here's I'm not sure whether you can see this or whether I'm sitting in front of it. But basically, I already have the port open for 8080. You might get an additional button here, open the port and make it public. You want to do that so that you can access it. And then you can open the browser. So I can just do that again. I had one from earlier, but I can just do that again. And this is what you should see. Again, I think this is really nice how Gitport handles this for you. So it gives you all the controls. For example, you can go back into the terminal and you see here, this is your open port, right? And then you can open the browser or make it private again. And I think it's very neat. And there's the Swagger. So it's been running. And give us a shout if you're there and if you got to that stage.
I'm late. No. Nothing yet.
Yeah, let's wait a little bit. Play a little bit with Swagger in the meantime. How's the chat looking? Is it busy?
Yeah, only summed up. No.
Oh, perfect.
Really something I love.
Oh, very good. So how many people are coding along so I get approximately an idea what's going on? Because I can't see YouTube.
No, it's not the quantity, the quality. We do have 20 viewers and people doing the exercise with us.
Okay. Oh, perfect. Wonderful. So you're all there? So perfect. So now you can go and play with Swagger and test it, right? So you can do exactly the same things that I did before. So, let's first of all look at the task. All tasks, we treat the complete list of tasks. Try it out, execute it. There we are. So this is a task created by the test. This is the second task created by the test. These are the two tasks that we put in earlier. And I show you a couple of Swagger things here as well. So if you wanted to create a new task, right? We try it out. So this is actually I think this is just a dummy UUID that is being inserted here. So because we're not yet using the statement preparation, which actually is preparing this UUID. So Swagger is just showing you that what we're actually creating later will be a different UUID. And so if we create, we just created another one with the default value of string, and we see here the UUID that was created is actually different than what Swagger proposed us here, right? So because this is basically just a dummy display for this field, but this was created by, when we created our statement in order to insert the data there. So if we wanted to delete this task, we then need to take this UUID from here and, for example, or if you want to update it, let's go with patch it. Let's patch it and give it a better name. So try it out. The patch is basically the update here. So, and we want to patch it for a better title. So, there we are. So again, this is just the one thing that catches us out here, that it uses this dummy one to create it because Swagger doesn't know about the UUID before it actually reads the data. But it uses the correct here that we inserted, and we have it with a better name. And if we then run this one, there we go. We have a better named task in there, and we have it with the proper UUID. And then we can just go and delete it. So use it. Use this one, and go and delete. Where is this? It's getting really big here, so this is a bit smaller. This is delete all tasks, and this is the patch. So this is the specific delete here. I'm going to try that out. Put that in. Execute it. There we are. We get a 204 code. This is quite nice about Swagger, that it shows you what are the possible codes that you can get back from there. And then again, we can check and see here it's been deleted. So in the case of the delete, there's not a lot of responses we can get, but for example, in the get, there's a lot of different example responses, and I think this is what's blowing up the REST controller a little bit, because we have all these annotations for Swagger, which is basically our UI for this app at this stage, right? So for example, we have the successful operation, what we would get, we have the example response for an invalid response, or if the task is not found. And you will see them all in the controller here, where we define the operation and we define the various responses that we could get, and they're annotated. So this is what might make the file a bit longer than what you expect for this simple app. Okay. So how is everybody doing?
So far, so good. Oh, in case of patch, shouldn't Swagger send only the data to be changed? Yes, and
it's not how we implemented it, right? So the way we implemented the patch is basically we're using the upsert function.
True,
right?
true. And Cassandra, any save is an upsert if it already exists. So we don't have to bother about fields. They will be all updated. That's not a big deal.
If you think,
if
you think it through, in order to just insert the data that's missing, right? You could probably just insert the data as missing. That's also fine, but you would still need to have you would have to implement a different method, right, in order to just have this partial update. So it's much easier to just insert the whole the complete. But I think it's a better practice anyway, isn't it? So to keep it in case you lose a partial update, right, and then someone else updates, they get a different state, right? So it's better if you have keep the state together of the task. I think that's my 2 cents. So it's like to make sure that you're not suffering if only certain nodes see an update and others not yet, right? That's how I would say it. What do you think, Cedric?
No. So, and the way the REST API is implemented, you need to provide an object. So, and the full object is serialized as JSON and sent like that. So maybe using something like GraphQL, you can only, as a request, provide what you need and what needs to be changed. But to be honest, under the hood, it will probably recreate an object from what exists in the database, override, and just save again. So yeah, there is no easy way to only, I want to only save the column number 3. Now, under the hood, there will be it will save the full object.
Any more questions?
No, only happy people.
That's awesome. Good. I think, oh my God, yeah, we've definitely gone through this quite quickly because, so yeah, why not? Let's go to MENTI, huh? So now that everybody's happy and make people even happier, right? So, and play a little bit more with MENTI. How about that? So let's see. Now you said I need to hit enter in order to make it work? Or?
I think it's on next one. This one is just an image. If you go to next, yes, now you will wait for players, and only when you decide with pressing enter, you will start.
Okay. Oh, did I click? Oh yeah, press enter to start the countdown.
Exactly.
Oh, perfect. I think everybody has a chance to get onto the leaderboard today.
Oh, true, yeah.
Yeah, so wonderful. Okay, perfect. So let's wait a little bit. I think everybody can win something today. It's the best chance ever. So cool. Okay. I don't need to wait more. I think we don't have that many people in it. We've got 12.
All right.
Should I wait?
Yeah, that's okay.
Okay, cool. Good. Microservices are, look at your phone, don't look at, microservices are the method to ensure tight coupling, the way to isolate domains, workloads, and reduce coupling, require enterprise service bus to communicate, good only on Raspberry Pis. So, answer fast. But you will end up on the leaderboard, I'm sure. Oh, very good, very good. Cedric, I think that's you with the Raspberry Pi.
I don't know, maybe?
Very good. Everybody understood what microservices are. That's amazing. Perfect. Next one.
Okay, leaderboard.
Leaderboard. This is the first time I'm presenting Menti myself. So
yeah,
normally
congratulations. The first time.
It works, yeah. Oh, that's awesome.
Ashish, HKB, oh, what a surprise.
Oh, perfect. Yeah, so, and I think Sakura went for the Raspberry Pi. So let's
Vinod is there as well.
The next one.
Okay.
Question 2.
And now you also need to tap enter for start the countdown.
Of course. Sorry about that.
No, that's okay, but that makes people start at the same time. Boom.
How many sessions objects should you use in your app? 1 per application, as many as are needed, 1 per connected client. Should I have to do anything, really? It's just your opinion, isn't it, Cedric? It's just your
opinion. Yes, it is. But today is just you working.
Yeah.
I'm watching.
Very good. Yeah, don't do 1 per connected client, especially if you have a lot of connected clients. So 1 per application. And let's see the leaderboard, how it changed. This is so funny when we have so few people. That is amazing. This is nice. Okay. Wonderful. Cool. I don't think there's been any change. I think it's the same leaderboard as before, same top 3. Right, you have to be fast. These are fast people if you want to overtake them.
Yeah.
So look at the next one. Question 3. Oh, and I have to start the countdown. Okay. What is Astra? This is a very, very difficult question. So you have to be really fast. It is a local in-memory version of Cassandra. It is Cassandra as a service in the cloud. It's a development tool. It's a gateway to the stars. So let's see. I want to see who gets that wrong. Yeah, nobody got it wrong. This is amazing. Even the DataStax people didn't get it wrong this time. This is perfect. Very good. Thank you very much. And leaderboard. Who was fast? You have to be fast to beat the top 3. I think no change as far as I can see. No change. Okay. Right. I keep forgetting to hit enter. Okay, so there we go. Sorry about that. So everybody, why should you prepare statements? To ensure they are ready for the send stage. Prepared statements are required to speed up queries, to properly cook them for your guests. Okay. Yeah, it's really to speed up the queries. I mean, like you could sort of say to ensure that they're ready for the execution stage as well. I think, but this is really the reason why you would want to go for prepared statements. Okay, obviously you don't have to cook them. So what does our leaderboard look like?
Wow.
We've got
no change.
We can change. Ashish has moved up one. So that's it's still the same 3, but Ashish was a bit faster. Excellent. Okay, and now the last one. I will learn it at some point. Using result set all is a good practice to retrieve results. Yes, no, I like using all available memory in my application all the time. Definitely seen that happening. Very good. Perfect. Yeah, so I think I would have chosen this one. Okay, so let's see who our leaderboard are. So thank you so much, guys, for playing along. Akshay, there you go. You're the leader. All three top, please identify yourself to Jack Fryer or to our other helpers in the Slack and in the YouTube chat or in the Discord, and make sure that we get all your address details and everything so we can send you some swag.
True.
Thank you very much. And I hope you liked it. Good. And okay, so let's have a quick look here at the bonus exercise. We actually do have some time, but I'm not going to start it up. But perhaps you can show it to you a little bit. Should we just perhaps quickly introduce the to-do MVC and what you would need to change? So it's something that let's just go perhaps to the to-do MVC web page. How about that? What do you think? And so because Cedric actually feels this is really quite nice, and Cedric can probably talk a little bit about this. So first of all, you know, the to-do MVC, or just let's have a look at the to-do backend first. And, because it comes with a lot of prefabs for you. So as it says here, it's a shared example to showcase a lot of different backend tech stacks, right? So you can basically implement your to-dos in so many different ways, right? So and they all use the same. You all use the same model, and then you have also a clearly specified way of testing them. So and I think that's where the that's what this project is really about, right? So this is so you can perhaps you can say a little bit more about it. We don't actually have a Cassandra.
Yeah, I need to make the pull request over there. It's a GitHub under the hood.
So and as you see here, so you can implement it. Then you can always look at the code, and you can run the specs, and you can have a look at the example implementations, right? So if I, for example, go here, and then it lets you sort of like, you know, try it out. And you do the same as before, right? So it's just like, and it basically comes with this unified client, right? So you can always use the same client, or you can use different clients that all look similar in order to test out your various interfaces and your various REST APIs that you've created with these different technologies. So it's something that you could do as a next stage, right? We haven't done it today because it actually uses a slightly more complicated data model, right? In order to keep sort of like the feedback with the test spec, you know, so you have to generate some URLs in your model and keep them there. And we just wanted to make it a very simple example today. But Cedric has gone through the entire effort in the past and put up actually an amazing workshop on this one, where you can just access it from the center here. This is the Microservices Java workshop online. And you have all the very detailed instructions in there. And it also tells you, you know, how we're using the to-dos backend client in order to use this as the proper front end, not just Swagger, but as a proper front end for our API. But I'll show you a little bit, you know, what's different, because I went through the exercises to simplify it. And perhaps you excuse me that I took these steps and make it perhaps quite simple. So this is a little bit differently set up here. And here the model. And you see we have a couple of different classes here that basically all do similar things, right? So this is the task that implements the basically the model for the task, task class here. So with our API, and so with our fields here. But then I think what we need in order to fully support the public testing is this task resource here. And so this has a couple of additional things here, so the string URL, for example, in order to support this external testing. And so I thought for today, it probably was a little bit more complex, but you are absolutely encouraged to go through the entire workshop here. It's very well documented and has a lot of interesting details here about a to-do MVC, and there's a full recording as well. So something that we've delivered earlier, and you can just go through it all again. Anything you want to say about that? It's your thing.
No, so why we don't did the full workshop today, in there, the object that is exposed should return a URL just to be able to navigate from the list to every single to-do object and interact with it. And so you want to create some mapping between the table and the object you want to create. And also when you create something, you don't have the ID, you can create the ID on the spot. And doing all this mapping from the controller to the repository is simply boilerplate code, not very interesting to understand. So we would rather, do the single repository with a single object and just show you how to use it.
Exactly. But I think what is really interesting then, if you want to explore what I found interesting is that you have, the to-do MVC project, which allows you to try out a lot of front-end technologies as well, right? In order to, to build your UI. So if you want to build the full app, you can really test a lot of things here and see, what you like best and what you feel like, Polymer here played with that, and then TypeScript and React, and then there's also vanilla JS. So it's, I think it's really a very interesting project. So you have the different backends that you can try out, and you have the different front ends that you can try out, and sort of like plug it together in a way that you feel comfortable with the various technologies. So I think it's something really worth exploring further. Okay. Good. So yeah, I think that was it. I think we have a last slide in Menti to get a little bit of feedback, right? What we can do better next time. And I don't know who put that.
Who did that? Okay, that's Jack.
David.
Okay, no. I know who he is. You should be sleeping at this time. Touché.
Right, do I need to press enter or just...
Yes, please.
Oh, I think I did that too.
To pause the scroll, so no, should be fine.
Oh yeah.
Oh, that's so funny.
That's so funny. So I should have reset. I think there might be from a previous test. I don't know. Yeah, have some more feedback. We really want to know was anything difficult. Was the content right?
And do you like it to run more content on Spring or anything else?
Yeah.
We have more coming, reactive, Spring Data, but also other topics like getting started with Docker. We try to cover a wide range of topics, but help us prioritize.
Oh, I like the clapping. Thank you, and I like that more an internal Spring. Yeah, definitely. I think. Okay, yeah, definitely. Cedric can write the code.
Live coding, yeah. But then, yeah, this is like a show. You are just watching me doing an app. Maybe there should be a format we could try. That put a lot of pressure on me, but starting from scratch. Let's create an app, the to-do app from scratch.
I think personally, I actually really like watching other people write code as well,
Okay,
because
so
I
live
learn
coding.
a lot more from how they're doing things.
Yeah, but
like,
you know, probably, yeah, it would probably take me, maybe 2 hours. I can do the to-do app working, probably, yeah.
Yeah, oh, that would be quite cool, actually. No, you've got a challenge there. That's good.
Enough challenge, yeah. But
more music. Yeah, I'm not good. Yeah, we should have some music on it.
yeah,
So that's, David is the good guy for
more
writing
Java
the
Spring
music in the
Boot.
background.
Okay, it's coming. Nice. All right, perfect.
Good. Well, thank you very much, guys. You know, it's really quite nice to work with such a small group and get some you know, I think it's awesome that some of you really try to code along. It's wonderful, and I hope you do some more stuff. We are not going away, of course, you know, so you can still ping us in Discord, or you can go to community.datastacks.com, put your questions in there, and we definitely want to hear your feedback and also suggestions, right? And even if you want to just provide some Menti questions, because we always struggle to come up with some good questions. So let us know what we can do in our workshops.
All right. So
then I think I have a last slide with some additional projects that you can try. And
yes, other slides are on the GitHub this time, so you can go and click there, download them, and have links to other kind of microservice, REST, GraphQL, Kafka, serverless, gRPC. We create a lot of samples. We simply pick some to do some workshop with. All right then. Thank you very much again, and see you next time. Bye.
Take care. Bye-bye.